Okay, so we've just done the primary alcohols. We're now going to look at the secondary and tertiary alcohols and then try and bring all of that together. So the secondary alcohols, they oxidise as well. They turn the dichromate from orange to green. And they undergo really the same process that the primary alcohol underwent when it made the aldehyde. So if you remember what happened with the primary alcohol, we lost that hydrogen there and this hydrogen here, which then combined with that oxygen to form water, which then leaves you with a double bond, which is going to form here, which gives us this product over here. And this product over here is a ketone. I mean, aldehydes and ketones are very similar because they both have this carbon-oxygen double bond, but with a primary alcohol, the carbon-oxygen double bond is at the end or beginning of a molecule, whereas with a secondary alcohol, because the OH is on a carbon that is within the chain, not the beginning or the end, then the carbonyl group, the C double bond O, must also be within the chain and not at the beginning and the end, and that's a ketone. So the process is exactly the same. The thing about this, though, there's no distillation required here because the reaction literally only goes from a secondary alcohol to a ketone. So the thing to do here is you just reflux it until there's no secondary alcohol left. At that point, you've got your propanone. Tertiary alcohols, they can't be oxidised, and I'll show you why in a minute. That was the one, if you remember, the boiling tube with the orange stuff in stayed orange. So tertiary alcohols cannot be oxidised, okay? And I just kind of want to bring all this together really in a summary of the last video and this video here, that the primary alcohol, if you remember, can be oxidised in the first step to form an aldehyde, and the aldehyde can be oxidised further to form the carboxylic acid. Okay, secondary alcohols, which is the one that I've just done, can only be oxidised to form a ketone, and tertiary alcohols cannot be oxidised at all. We can have a look at that a bit clearer if we have a look at the structures of these and have a look at what is happening. Okay. So with the primary alcohol, if you remember the stage that we were looking at for the first instance, going from a primary alcohol to an aldehyde, we lost that hydrogen there on the OH group. All right. We have a double bond that forms between the oxygen and the carbon here. And because of that, we need to lose this hydrogen here as well. And if you look at the secondary alcohol now, that has all of that criteria, okay? So just like the one above, we can remove that hydrogen there. The double bond will form here, and we lose another hydrogen that is on that carbon as well, which then gives us our ketone over here. Now, this can't happen with a tertiary alcohol, okay? So if I try and apply exactly the same process to the tertiary alcohol, yes, I have that hydrogen there, and if that removes, I would form a carbon-carbon double bond at this position here. But what I haven't got now, which I did with the primary and the secondary alcohol, is I haven't got a hydrogen coming off this carbon to remove. And that's why the tertiary alcohols cannot be oxidised, okay? So the summary of all of this really is this. You need to know that a primary alcohol forms an aldehyde. You would distill if you wanted the aldehyde, but you can take a primary alcohol and oxidise it to a carboxylic acid, but to go all the way you need to reflux. The secondary alcohol can be oxidised to form a ketone, and again, you would reflux that one because you're going all the way to the end. There's only one step. You can't go any further anyway. And the tertiary alcohols cannot be oxidised at all. Okay? And I think, a relatively short one, but I think that's probably the best place to stop for that one.